So assalamu alaikum everyone, and in this video I'm going to talk about circular motion yet again. And I'm presuming that you guys have already gone through my previous video in which I've explained what circular motion is and how angular displacements, angular velocities and angular acceleration are related to each other. And if you guys have not watched that video and lazy enough to not to click on the link that is given here, then you can simply understand it in simple ways that these three variables in circular motion are related in the same way as the linear acceleration, linear velocities, and linear displacements are related. Let's take, for example, the first equation for linear motion. V equals u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is time. In the circular motion, we will have omega equals omega naught plus alpha t, where omega is the final angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration, and t is time as always. And in this video, I'm going to talk about unit vectors along the radius and the tangent. And for that, let us assume a particle executing a circular motion about a point O. And for ease, let's take point O as the origin of the xy plane in consideration. At any instant of time, let us assume that the particle is at position P, where OP is making an angle theta with the x-axis. To get the sense of direction for the radial vector, let's extend the line OP to point A, and ER will be the unit vector or the directional vector for PA. Now, to get the sense of direction for the tangential vector, let's draw a line perpendicular to OA from point P to point B. And the directional vector of this PB will be the direction vector or the unit vector along the tangent. Let's denote it with ET with an arrow on its head. And now we will write PA and PB in vector forms. To do that, we will simply take the component of PA and PB along x and y axis, and we will make the component along x axis as the coefficient of I and the component along y axis as the coefficient of j. So the component along x axis of PA is PA cos theta, since it is making an angle theta with the x axis, and the component along y axis will simply be PA sin theta. Okay. So the PA vector can be written as PA cos theta I plus PA sin theta j. Whereas in case of vector PB, the component along x-axis will be a little bit different, since PB is making an angle theta with the y-axis. So the component along y-axis will be PB cos theta, and the component along x-axis will be PB sin theta with a minus sign on it because it is in the opposite direction or the negative x-axis. So the vector of PB or vector PB can be written as minus I PB sin theta plus j PB cos theta. Now we will have to understand what a unit vector is. A unit vector is basically a vector which have a value 1, a magnitude of 1, which means that it is only denoting, or it is only showing the direction of a vector. So what we will do, we will simply divide the vector with its magnitude to get the unit vector. So the unit vector of PA, the ER, will be I cos theta plus j sin theta, whereas the unit vector ET along the tangent will be minus I sin theta plus j cos theta. That's it. Hello everyone, I understand that this is a little too late, but I'm here to apologize for not uploading videos in the past few months. If you like this format of my videos, please give it a thumbs up, and I understand that this video is a little bit short, but in the next video I will catch up from where I left today, inshallah, and in future I will try my level best to upload videos a little bit more frequently than what I was doing in past. Okay then, assalamu alaikum, see you in the next one.